Welcome to Sleep Metric Science, where we cut through the noise and look at what the sleep data actually says. Your watch tells you that you got 1 hour and 42 minutes of deep sleep last night. It says that with a confident little number and a clean bar on a graph. But here is something most people never stop to ask. How does a device strapped to your wrist actually know what stage of sleep your brain is in? The honest answer is that it doesn't. Not really. It is making an educated guess from the outside of a process that happens deep inside your skull. And once you understand how that guess is made, you will never read your sleep stages the same way again. I spent 15 years working inside hospital data systems, integrating the kind of medical grade monitoring equipment that clinicians actually trust. So when I look at a consumer sleep tracker, I am not looking at it as a gadget. I am looking at it as a measurement system and asking the same question I asked of every clinical interface I ever built. What is this thing actually measuring, and what is it only inferring? With sleep stages, the gap between those two is enormous, and nobody selling you a tracker is in a hurry to explain it. By the end of this video, you will understand exactly what a real sleep lab measures that your watch never can, why the 4-stage breakdown on your app is closer to a statistical model than a recording, and how to actually use your sleep stage data without being misled by it. This is not about throwing your tracker in a drawer, it is about knowing the difference between a measurement and an estimate. Let's start with what sleep staging actually is. When a sleep scientist scores your sleep in a lab, they are not guessing. They are reading 3 direct signals from your body. The first is brain electrical activity, measured by an EEG, with sensors placed on your scalp. This is the single most important signal because sleep stages are defined by brainwave patterns. Deep sleep, for example, is literally defined by slow delta waves sweeping across the cortex. The second signal is eye movement measured by an EOG. This is how the lab identifies REM sleep, the stage where your eyes dart rapidly beneath closed lids. The third is muscle tone, measured by an EMG, usually under the chin because your muscles go nearly paralyzed during REM. Brain, eyes, muscles. 3 direct electrical readings from the actual systems that define each stage. Here is the problem. Your smartwatch has access to none of those 3 signals. It cannot read your brainwaves, it cannot track your eye movements, it cannot measure the muscle tone in your jaw. It is sitting on your wrist as far from your brain as a wearable can reasonably be, trying to reconstruct what is happening in your central nervous system using 2 crude proxies: how much your wrist moves and the rhythm of blood flowing through the vessels in your skin. That blood flow signal comes from those little green lights on the back of your watch. It is called photoplethysmography, or PPG, and it works by shining light into your skin and measuring how much bounces back as your blood vessels expand and contract with each heartbeat. From that, the watch derives your heart rate and, crucially, your heart rate variability. The wrist movement comes from an accelerometer, the same kind of motion chip in your phone that knows when you have turned it sideways. So think about what is really happening here. A sleep lab measures the brain directly. Your watch measures your pulse and your fidgeting, and then runs those numbers through an algorithm that says, in effect, based on this heart rate pattern and this stillness, a person is probably in deep sleep right now. Probably. That word is doing an enormous amount of work, and the app hides it behind a clean, certain-looking chart. When I first started comparing tracker output against the validation studies, what surprised me was not that the watches were wrong. It was how specific they pretended to be while being wrong. The research on this is actually quite clear. Most consumer wearables are genuinely good at one thing: telling whether you are asleep or awake. That binary judgment, sleep versus wake, is often accurate 80 to 90% of the time because it mostly comes down to movement and heart rate dropping, and those are things a wrist can actually sense. But the moment you ask the watch to break that sleep into stages, light, deep, and REM, the accuracy falls off a cliff. Independent studies that put trackers head to head against laboratory polysomnography have repeatedly found that staging agreement is poor. Some devices correctly identify deep sleep less than half the time. They routinely confuse light sleep with REM, and they miss the brief awakenings that fragment your night, because a brief awakening where you lie perfectly still looks to an accelerometer exactly like sleep. Here is how I look at it. Your tracker is reading the shadow of your sleep, not the sleep itself. Heart rate variability does genuinely shift across sleep stages. That is real biology, and it is why the estimate works at all. During deep sleep, your nervous system calms and your heart rate steadies. During REM, it becomes more variable and more active. So the algorithm is not inventing things from nothing. It is catching the downstream echo of what your brain is doing. But an echo is not the original sound. Two different brain states can produce very similar heart rhythms, and when they do, the watch has no way to tell them apart. It just picks the more likely one and draws the bar. This is exactly the kind of problem I dealt with constantly in clinical integration. You have a signal that correlates with the thing you care about, but it is not the thing itself, and the danger is that everyone downstream starts treating the proxy as if it were the truth. A number on a screen has a way of erasing all the uncertainty that went into producing it. The mistake I see people make is treating their deep sleep percentage like a thermometer reading when it is much closer to a weather forecast. And there is a second layer to this that almost nobody talks about. Every tracker company uses its own private algorithm, and they tune those algorithms differently. This is why you can wear two different devices on the same night and get two completely different stage breakdowns. They are not measuring different sleep. They are running the same rough inputs through different guesswork. So when you compare your deep sleep number to your friends, you are not comparing your sleep to their sleep. You are comparing one company's statistical assumptions to another's. That comparison is close to meaningless. So what do you actually do with this? Because I do not want to give you hype. I want to give you what actually helps. Here is the framework I use, and it comes down to 3 rules. First, trust the trends, not the stages. Your watch is far more reliable at tracking change over time than at any single night stage breakdown. If your deep sleep estimate is consistently lower across 2 weeks of late caffeine or alcohol, that pattern is real and worth acting on, even if the exact numbers are soft. The shape of the curve is more honest than any individual point on it. Second, anchor the estimate to how you actually feel. Your body is a better sensor than your wrist. If your watch says you got great deep sleep but you feel wrecked, believe your body. The estimate failed that night. If the number and your energy agree, that is when the data is genuinely telling you something. Third, use the one metric your watch measures directly, not the ones it guesses. Resting heart rate and heart rate variability are actual measurements, not inferences. Watching how those move night to night will tell you more about your recovery and stress than any color-coded stage chart ever will. The irony is that the most useful data on your sleep tracker is the data the marketing barely mentions. Here is what I want you to take from this. Your smartwatch is not lying to you, but it is far more confident than it has any right to be. It is a clever device making a reasonable guess about something it cannot directly see. Once you hold it that way, as a trend tool and a rough estimate rather than a medical readout, it actually becomes useful again. The goal was never to have perfect numbers. It was to understand your own patterns well enough to change one thing that matters. If you want a clear, science-backed way to actually improve the sleep underneath all those numbers, head to sleepmetricscience.com and download the free Deep Sleep Protocol. No pills, no supplements, just the fundamentals the research genuinely supports. The link is in the description. I will see you in the next one.